Hey everyone, today we are going to look into one of the classic system design problems that shows up in the interviews, and it is the least recently used cache or LRU cache. Design a data structure that follows the constraints of a least recently used LRU cache. Implement the LRU cache class. LRU cache int capacity. Initialize the LRU cache with positive size capacity. int get int key. Return the value of the key if the key exists. Otherwise, return -1. Void put int key int value. Update the value of the key if the key exists. Otherwise, add the key value pair to the cache. If the number of keys exceeds the capacity from this operation, evict the least recently used key. The functions get and put must each run in O of 1 average time complexity. Okay, so we need to design a cache that stores the key value pairs, but if we go beyond the capacity, we have to evict the least recently used key. So we can use a hash map because hash maps are good at storing key value pairs and O of 1 lookups updates, but how do we know which is the least recently used? That's why it's gonna get tricky. So let's say we are adding keys like this: put 1 comma 1, put 2 comma 2, get 1, and put 3 comma 3. But now we have reached the limit and we have to evict entry, but which one to evict? So it's not enough to store the key value pairs, but we also need to store the usage order. So here we are going to combine two data structures, a hash map for O of 1 access to values and a doubly linked list. For O of 1 updates to usage order. So here the hash map will map the keys to the linked list nodes. Each node stores the key and the value and pointers to previous and next nodes. This way, whenever we get or put a key, we can quickly remove the corresponding node to the end of the list, marking it as the most recently used. And when we are out of room, we can evict out the node at the head of the list, the least recently used item. So and also removing a node from a doubly linked list is in O of 1. That is also doable as long as we have the pointer to it. So here is the list node. This is how the list node looks. We have two pointers, nest and prev. We have key and values. The list node stores key and values. So here every node knows its key and value, and this is helpful during the eviction. So here we have the int capacity. So here we have a dummy head and a dummy tail. So here I'm using sentinel nodes, which are the dummy tail and dummy head, to avoid these edge cases where we have to check if head or tail is null, and this makes the code much cleaner. Then let's add some helper methods, add and remove. So here, when we add a node to the tail, it means that it was just used. So when we remove a node, means we're about to evict or update. And then now I'm going to add the get and put methods. So I think this should be a fully functional LRU cache in O of 1, time per operation, and here we are using a doubly linked list for tracking the order and a hash map for fast access. So a hash map does the quick lookup and linked list handles the order. Some languages like Python offer ordered dict, and Java has linked hash map that can solve this out of the box. But if we are asked to build it from the scratch, this is how we do it. So let me run this code. 46. Okay, it's void. and okay, thank you for watching. Let's see you in the next video.